Welcome to this podcast. We're joined in the studio by our guest today to talk about an editorial published in the journal Clean Technologies and Environmental Policy, which discusses decarbonization and the myths surrounding it, myths that have become unquestioned truths and dangerously oversimplify a highly complex reality.
Thank you. It's a pleasure to be here.
The editorial touches on something fundamental, decarbonization. It argues that certain ideas about how to achieve it have turned into axioms, myths, as the article puts it.
Exactly. These are oversimplifications that can be dangerous in the face of such a complex challenge. Decarbonization involves technology, economics, and society. It's a very delicate balance.
And with so many technological options on the table, CCUS, green hydrogen, electrification, bioenergy with carbon capture, it's a fertile environment for myths to flourish.
Yes, that's why the editorial makes an important point. We need to return to core science, physics, chemistry, engineering, and use critical tools like life cycle assessments to understand the real impact and the trade-offs involved in each choice.
Let's unpack some of those myths. How about starting with one that seems so logical? If it's bio-based, then it must be sustainable. After all, it comes from plants, something renewable.
It does seem logical at first, but the reality is much more complex. The sustainability of a bio-based product depends on a long chain of factors. What kind of plant is used? Where is it grown? Was deforestation involved? How much fertilizer and pesticide were required? What's the industrial process to transform it? Life cycle assessments, which evaluate everything from start to finish, show that many bio-based products don't deliver the environmental benefits we expect. You really have to analyze each case individually.
So a bio label isn't enough. That same kind of thinking also applies to another popular myth. If it's renewable, it's sustainable. People tend to see solar and wind as the perfect, clean solution.
No doubt they emit far less than fossil fuels during operation, but they're not free of impact. Manufacturing solar panels, wind turbines, and, a key point, the batteries needed to store this intermittent energy all require extensive mineral extraction, and that has environmental and social costs. There's also land use to consider, and of course, the intermittency. The sun doesn't always shine, and the wind doesn't always blow.
Right, that means you need huge storage systems or backup energy sources, which adds even more complexity.
Exactly. You have to consider the entire system, not just the operational phase.
That brings us to another myth. If it's low carbon, it must be sustainable. Technologies like CCUS or electric vehicles often seem like unquestionable solutions.
They are important tools for reducing emissions in certain sectors, no question. But sustainability is broader than that. Where do the resources come from to build and run these technologies? What's the environmental footprint of producing electric vehicles and batteries, for example? CCUS can be energy intensive, and in some cases, it's even used to justify continued fossil fuel production. You can't just focus on carbon emissions alone. True sustainability requires a much more holistic perspective.
So even if we cut carbon in one place, we might be creating new problems elsewhere, environmental or social.
Exactly. That links to another point raised in the editorial, the overly optimistic belief in disruptive technologies that promise to fix everything overnight. The idea that one brilliant invention will save us all.
But real innovation is usually a gradual process, right?
Absolutely. It's not just about inventing something in a lab. You need infrastructure, regulations, new markets, and public acceptance. Most technological progress is incremental. We need innovation, yes, but we also need to recognize barriers and use proven engineering solutions that we can implement now. It's about balancing long-term dreams with short-term action.
A necessary balance. So the editorial's core message is really a call for scientific rigor and evidence-based thinking.
Exactly. We need to critically examine any easy sustainability promise, whether it's coming from bio-based products, renewables, circular technologies, or low-carbon solutions. It's essential to understand the trade-offs and limitations of each option and focus on strategies that are realistic, not magical.
That makes a lot of sense. Decarbonization has no silver bullet. It's about building a diverse portfolio of solutions and carefully evaluating each one, not just for the climate, but also in terms of economics, social impact, and energy security. A huge challenge, no doubt.
Absolutely.
Thank you so much for this insightful and nuanced discussion. It was a pleasure to explore these critical issues with you.
Thank you for the opportunity.
And to our listeners, perhaps this conversation will spark a deeper reflection on how we talk about climate policy and make decisions, both in our daily lives and on a global scale. Thanks for tuning in. And until next time.